Hello everyone, I'm Mason Egger, and today we're going to be talking about the enters and exits of context managers. If you've ever programmed in Python before, it's likely that you've seen some sort of statement that looks similar to this. The with statement along with a function, could be open or something else, with a variable declaration, and then some code that is run within the context of this. These are what are known as context managers, also lovingly called the with blocks. Context managers guarantee that some operation is performed after a block of code, even in the case of an exception, return, or exit, and these were designed and put into Python to simplify the try finally pattern. And they allow for more reusability and cleaner code and are considered more Pythonic. There's lots of different reasons why you would want to use a context manager. You could be spinning up or tearing down some resources, such as a file handle or socket connections, database connections, game environments like PPB, or many other things, along with managing global state, locking, mocking and testing, logging, and there's just so many more things. But how do you implement your own context manager for you to use? Well, context manager implementation is actually relatively straightforward. They can be implemented as a class and are implemented using the dunder enter and dunder exit magic methods. As we can see here, we have a class, my context manager, that says def enter, return here, and then def exit with some parameters and pass. And if I were to import this context manager and try to print the word hello, I would get hello, but I would also get here because I am printing out the variable that I was assigning the context manager to, CM in this instance. So what exactly happened here? The enter method, everything within the enter method is executed at the very beginning before the with block is ever even entered. It is a magic method that only takes one argument, self, and it is used to establish connection, modify system functions, set up anything, whatever you want it to do. If you are going to be modifying any system functions or anything like that, it is a wise idea to keep an original copy of anything that you modified so you can change it back later when you're done. And it must return a value that is stored in the variable specified by the as, which is how we are able to print something out with it. So an example of this here would be, let's set all of the text to uppercase and say that we're yelling. So in this enter method, we're going to modify standard out. We're going to create a specific method that sets all of our text uppercase and set that to standard out. And then whenever we import it and we say print hello, it should come up as uppercase, and then it should, we would think that it would go back to normal, and then it would say, I'm not yelling. I should not be yelling, but in this instance, it is not, and that is because we have done nothing with the exit method to set it back to normal. So the exit method is the second half of a context manager, and it is executed after the entire body of the with statement. It returns a Boolean flag indicating if any exception that occurred should be suppressed. If true is returned, the exception will be suppressed, otherwise the exception will continue to propagate up until somebody handles it. This method takes three arguments, exec type, exec val, and traceback, and these essentially are the exception class, the exception instance. Sometimes parameters passed to the exception can be found in execval.args, and a traceback object in case you need to do any debugging. So an example of this would be, let's go ahead and fix our previous example. We still have our yelling context manager where all of our text will be made uppercase. But now what we're going to do is in the exit method, we're going to set it back to normal, which is what we did in our enter method when we said self.standardout is equal to sys.standardout.write. We actually saved it for ourselves so we could change it back later. So now that we've done this, it says hello, and then it says I should not be yelling. And as you see, when it prints out, it actually works and it says, I should not be yelling. Now let's focus on one statement that was in a previous slide that I do want to go over and touch just a little bit more. If true is returned from the dunder exit method, the exception will be suppressed. Otherwise, this exception will continue to propagate up. This means that you can do whatever you want with these exceptions. So what we're going to do here is we're going to say if the exec type is an exception, then we're going to print there was an exception, and then we're just going to ignore it and keep going. You probably wouldn't do this in real life, but this is just to prove that we did in fact see an exception. So we're going to go ahead and import our context manager again, and we're just going to erase exception. And then we'll see hello, and then it says there was an exception, but then as we can see, it said I should not be yelling, and it continued on just fine. But what about context managers that take parameters? Our dunder enter method only takes self as an argument. There's nothing there to take. How do we pass these? Well, whenever you call this with statement, in context, it calls the dunder init method. So if you want to actually pass anything in, then you need to write a constructor that takes these parameters. So if we were to re-implement the file open method that we've probably all used before, we would basically create a dunder_init method with self.name, the file mode, and the file handle. Then we would basically, in our dunder_enter method, open a file handle and assign it to self.filehandle with the name and the mode, returning the file handle back, and then at the very end we would close it. And if we use our context manager in this way, and then we use it like we normally would our normal open, it will work for us just fine. That's all I have for this time. Thank you very much. All of these code examples and more are on my GitHub. Be sure to follow me on Twitter @MasonEgger. Thank you very much.